Alright, hello and welcome back. In this video, we're going to look at what's called projectile motion fired at an angle. So let's start with that. So in the previous notes, we looked at something fired horizontally. That meant that we had to shoot it straight out. So fired at an angle just means that we're always going to shoot something up into the air where it's going to leave the ground or leave the top of the cliff at an angle theta. So as we learn how to tackle this topic, we are going to do what I call a golf ball problem. So this kind of goes along with the homework assignment here. So let's start with this. So it says a golfer takes successive swings and hits a ball at the following angles. Like at some point he hits the golf ball at a 10-degree angle, meaning that this theta is 10. Sometimes it's 20, 30, 40, all the way up to 90. All right, if the ball leaves the club each time with a velocity of 48, calculate whatever. Okay, so that means that he is always going to hit the ball with a velocity of 48 meters per second. So we can write that down. And we end up having to do this problem all of these times. So you don't have to do 0 and you don't have to do 90, but don't scribble them out because we're going to talk about them and fill them in class next time I see you. But you do have to do 10, 20, 30, 40, 50, 45, 50. So 1, 2, 3, 4, 5, 6, 7, 8. You have to do 9 problems here. So let's do our example, 40 degrees. So we are going to take the golfer and we are going to make him hit the ball at a 40-degree angle. And there are always 3 classic questions. One of them is how long is the golf ball in the air, how high up does it go, and how far over does it land. And so we're going to calculate these 3 things, and then you're going to write the answers in these boxes. Then you're going to repeat the problem for, let's say, a 45-degree angle, and you're going to get the same 3 answers and write them in the boxes. And we're going to be looking for some patterns in this chart, and then next time I see you in class, we will talk about the summary questions on the bottom. So really what I'm doing is I'm doing one example with you here on the 40 degrees so that you can do the rest of them in the chart, okay? All right, so we have our golfer hits the golf ball with a 48-degree or 48 meters per second at a 40-degree angle. So the issue is the golf ball then is going to parabola up and parabola down. Well, when we looked at our notes from here, we talked about how we really can't do things with parabolas. So in this set of notes, we just pretended instead that we were just going to drop something. So here, I really can't do a parabola up, but I could instead just pretend that I threw the golf ball like straight up. So parabola upping is going to be the same as throwing it straight up. So what we have to do is we have to take this 48 meters per second and we have to come up with the x component of that velocity and the y component of that velocity. And so I could make a little triangle here with this green arrow and I could like drop it down and I could say, okay, this is my x piece right here, this is my y piece, and what would those components be? And we're going to find the components using our trig the same way we did with vector addition, the component method in our component chart. Meaning that the x component is going to turn out to be the hypotenuse number, which is 48, times cosine of 40. And our y component is going to be 48 times the sine of 40. But in this problem or in these examples, I think it's actually going to be best to number crunch these right now. So this turned out to be 36.77 meters per second, and this one turned out to be 30.85 meters per second. So let's talk about that for a second. So if the golfer hits the golf ball 48 meters per second, it means that the golf ball is going to travel in the x direction in the air, 36.77 meters per second. And the golf ball is going to be going upward at 30.85 meters per second. So now that I know what the golf ball is doing in the x direction and in the y direction, I never need this information anymore. So I'm going to X it out. And the reason I'm going to X it out is it's going to hopefully help me remember to never use those numbers again. All right, so let's tackle the first question. The first question is the time in the air. How long is it going to take the golf ball to go up and then come down? So let's just start with the up. So it parabola's up. But again, we can't figure out this time. So when we were over here, we said the time to parabola down was equal to the time to just drop. So now the time to parabola up is going to be equal to the time to just throw it up. So let's try that. So I'm going to write down the initial velocity in the y direction is going to be what the golfer does. Not the 48, but this. The initial velocity in the y direction is 30.85. And then the ball is going to be parabola upping, so going straight up until it gets to this top. And at the top is when it would stop, so the final velocity in the y direction is going to be 0. And it's going to get slowed down by gravity, so I'm going to write down minus 9.8, and I want to know the time. So again, I'm just pretending I'm throwing it straight up. And if you look at those variables in our kinematics equations, you might recognize that I think this equation will work. Equation number 1, so I'm going to write it down. But I'm going to make sure that I put little y's in here because this is happening in the y direction. Final velocity is 0. The initial velocity is 30.85 plus a negative 9.8 times t. So we have 30.85. Whoops, got to turn that on. 30.85 divided by 9.8. And it takes 3.15 seconds to go up. So 3.15 seconds. All right, I'm going to write that on my chart. So it takes 3.15 seconds to go up. And being that this is a perfectly symmetrical picture, it's going to take 3.15 seconds to go down. So I'm just going to multiply this by 2. And that would equal 6.30 seconds is how long the golf ball is in the air. All right, the next question is how high up does the golf ball go? So that's really this, how high up. So parabola's up, but again, I can never find that, but it would be equal to this. So I'm just going to put a D in this list. And I think I can use this equation, the third one. So VF squared equals VI squared plus 2AD. This is going to be a 0. 30.85. That's the, oops, I forgot to put the y's. That's the final velocity in the y direction. That's the initial velocity in the y direction. Plus 2 gets slowed down by gravity, so I'm putting a negative 9.8 and a D. All right, so I got to move that 30.85 to the other side, which then I can make everything positive. So 30.85 squared divided by 2 divided by 9.8 will turn out to be 48.56. 48.56 meters. That's how high up it goes. All right, the next question is the range. So before we can do the range, we have to talk about the arrows here for a minute. So let's go back and talk about the arrows. So here's the golf ball at the start of the story. Let's kind of draw it nice and big. And I'll put the golf ball right here. I'll put the golf ball right here. Let's put them up here. And let's do 3 more here. So 1, 2, 3. All right, so what's happening in this story is on the way up, while it's parabolaing up, the golf ball is decelerating. And then on the way down, the golf ball is accelerating. So let's look at what would be happening to the y arrows, the VY arrows. It's going to be, the VY arrows are going to be slowing down by 9.8. So here's like a long arrow that stands for 30.85. So the next arrow is going to be shorter. And then the next arrow is going to be shorter. So they keep getting shorter and shorter. And up here, there is no VY arrow. The VY arrow is 0, like it disappears. That's what this means. It means I ran out of upward velocity, and that's why it's starting to go down. And then when it starts to go down and it accelerates, then the VY arrows are going to start to appear again, and they're going to get bigger and bigger and bigger when they come down. Because I'm accelerating and I'm decelerating and then accelerating. But now to do the range means how far over do you land. So that means like this, how far over. So I'm going to say dx, because it's like the distance in the x direction equals question mark. And that distance in the x direction is called the range. And just like our previous set of notes, in the x direction, things are constant. Things are constant. And so I have a constant velocity in the x direction, so I'm going to write that down here. Constant velocity. And I'm going to put my x arrows in. So here's my Vx arrow. And the golf ball in the x direction is going 36.77. So this arrow would be the same on this golf ball. It would be the same on this golf ball. And at the top of the path, there is a Vx arrow. It's right there. It's equal to 36.77. So the Vy arrow disappeared, but not the Vx arrow. And so I have constant velocity going on in the x direction. And because of that, I have to use the constant velocity equation to calculate the range. And I need to put little x's on here. So what is the velocity in the x direction? 36.77. I'm looking for dx, that is the range. And how long is the golf ball in the air? That time needs to be the time up and the time down, which is that doubled time that we did over there. So that's going to be 6.3. All right, so we have 6.3 times 36.77, and we get 231.65. 231.65 meters. And we'll box that. Okay, so then I'm going to take those answers and I'm going to write them in the chart. So this was 6.3 seconds, 48.56, 48.56, and 231.65. All right, so now what I need you to do is I need you to just use lined paper, and I need you to draw a new picture that looks like this. Make it parabola up and down. And you're going to change something. You're going to keep that 48, but you're going to change this angle. So now maybe do the 50. Do the 50. Don't do the 45 next. Do the 50. And figure out your new Vx and your new Vy. And since Vx and Vy change, that means everything changes. And you're going to get different answers on here. Chunk out those same 3 answers. Write them in the chart, and again we're going to be looking for patterns. So it would be very helpful if you had 10 through 80 done before I see you in class next time, and then we'll finish it up. Okay? All right, good luck.